Welcome to a new video. Today we are going to talk about a new topic. We will talk about the desert. How was the desert formed? What are the wealth and minerals that we depend on? We will learn a lot of information in a few minutes with Mr. Adam. So follow me. A desert is a barren area of landscape where little precipitation occurs and, consequently, living conditions are hostile for plant and animal life. The lack of vegetation exposes the unprotected surface of the ground to the processes of denudation. About 1/3 of the land surface of the Earth is arid or semi-arid. This includes much of the polar regions, where little precipitation occurs, and which are sometimes called polar deserts or cold deserts. Deserts can be classified by the amount of precipitation that falls, by the temperature that prevails, by the causes of desertification, or by their geographical location. Deserts are formed by weathering processes as large variations in temperature between day and night put strains on the rocks, which consequently break in pieces. Although rain seldom occurs in deserts, there are occasional downpours that can result in flash floods. Rain falling on hot rocks can cause them to shatter, and the resulting fragments and rubble strewn over the desert floor are further eroded by the wind. This picks up particles of sand and dust, which can remain airborne for extended periods, sometimes causing the formation of sandstorms or dust storms. Wind-blown sand grains striking any solid object in their path can abrade the surface. Rocks are smoothed down, and the wind sorts sand into uniform deposits. The grains end up as level sheets of sand, or are piled high in billowing sand dunes. Other deserts are flat, stony plains where all the fine material has been blown away and the surface consists of a mosaic of smooth stones. These areas are known as desert pavements, and little further erosion takes place. Other desert features include rock outcrops, exposed bedrock and clays once deposited by flowing water. Temporary lakes may form and salt pans may be left when waters evaporate. There may be underground sources of water, in the form of springs and seepages from aquifers. Where these are found, oases can occur. Plants and animals living in the desert need special adaptations to survive in the harsh environment. Plants tend to be tough and wiry with small or no leaves, water-resistant cuticles, and often spines to deter herbivory. Some annual plants germinate, bloom and die in the course of a few weeks after rainfall, while other long-lived plants survive for years and have deep root systems able to tap underground moisture. Animals need to keep cool and find enough food and water to survive. When they are nocturnal, and stay in the shade or underground during the heat of the day, they tend to be efficient at conserving water, extracting most of their needs from their food and concentrating their urine. Some animals remain in a state of dormancy for long periods, ready to become active again during the rare rainfall. They then reproduce rapidly while conditions are favorable before returning to dormancy. People have struggled to live in deserts and the surrounding semi-arid lands for millennia. Nomads have moved their flocks and herds to wherever grazing is available, and oases have provided opportunities for a more settled way of life. The cultivation of semi-arid regions encourages erosion of soil and is one of the causes of increased desertification. Desert farming is possible with the aid of irrigation, and the Imperial Valley in California provides an example of how previously barren land can be made productive by the import of water from an outside source. Many trade routes have been forged across deserts, especially across the Sahara, and traditionally were used by caravans of camels carrying salt, gold, ivory and other goods. Large numbers of slaves were also taken northwards across the Sahara. Some mineral extraction also takes place in deserts, and the uninterrupted sunlight gives potential for the capture of large quantities of solar energy. Physical geography. A desert is a region of land that is very dry, because it receives low amounts of precipitation, usually in the form of rain, but it may be snow, mist or fog, often has little coverage by plants, and in which streams dry up unless they are supplied by water from outside the area. Deserts generally receive less than 250 millimeters (10 in) of precipitation each year. The potential evapotranspiration may be large, but, in the absence of available water, the actual evapotranspiration may be close to zero. Semi-deserts are regions which receive between 250 and 500 millimeters (10 and 20 in), and when clad in grass, these are known as steppes. Deserts have been defined and classified in a number of ways, generally combining total precipitation, number of days on which this falls, temperature, and humidity, and sometimes additional factors. For example, Phoenix, Arizona, receives less than 250 millimeters (9.8 in) of precipitation per year, and is immediately recognized as being located in the desert because of its aridity-adapted plants. The north slope of Alaska's Brooks Range also receives less than 250 millimeters (9.8 in) of precipitation per year and is often classified as a cold desert. Other regions of the world have cold deserts, including areas of the Himalayas and other high-altitude areas in other parts of the world. Polar deserts cover much of the ice-free areas of the Arctic and Antarctic. A non-technical definition is that deserts are those parts of Earth's surface that have insufficient vegetation cover to support a human population. Weathering processes. Deserts usually have a large diurnal and seasonal temperature range, with high daytime temperatures falling sharply at night. The diurnal range may be as much as 20 to 30 degrees Celsius, 36 to 54 degrees Fahrenheit, and the rock surface experiences even greater temperature differentials. During the day the sky is usually clear and most of the sun's radiation reaches the ground, but as soon as the sun sets, the desert cools quickly by radiating heat into space. In hot deserts, the temperature during daytime can exceed 45 degrees Celsius, 113 degrees Fahrenheit in summer and plunge below freezing point at night during winter. Such large temperature variations have a destructive effect on the exposed rocky surfaces. The repeated fluctuations put a strain on exposed rock, and the flanks of mountains crack and shatter. Fragmented strata slide down into the valleys where they continue to break into pieces due to the relentless sun by day and chill by night. Successive strata are exposed to further weathering. The relief of the internal pressure that is built up in rocks that have been underground for eons can cause them to shatter. Exfoliation also occurs when the outer surfaces of rocks split off in flat flakes. This is believed to be caused by the stresses put on the rock by repeated thermal expansions and contractions, which induces fracturing parallel to the original surface. Chemical weathering processes probably play a more important role in deserts than was previously thought. The necessary moisture may be present in the form of dew or mist. Groundwater may be drawn to the surface by evaporation, and the formation of salt crystals may dislodge rock particles as sand or disintegrate rocks by exfoliation. Shallow caves are sometimes formed at the base of cliffs by this means. As the desert mountains decay, large areas of shattered rock and rubble occur. The process continues and the end products are either dust or sand. Dust is formed from solidified clay or volcanic deposits, whereas sand results from the fragmentation of harder granites, limestone and sandstone. There is a certain critical size, about 0.5 millimeters, below which further temperature-induced weathering of rocks does not occur, and this proves it as a minimum size for sand grains. As the mountains are eroded, more and more sand is created. At high wind speeds, sand grains are picked up off the surface and blown along, a process known as saltation. The whirling airborne grains act as a sand-blasting mechanism, which grinds away solid objects in its path as the kinetic energy of the wind is transferred to the ground. The sand eventually ends up deposited in level areas known as sandfields or sand seas, or piled up in dunes. Dust storms and sandstorms. Sand and dust storms are natural events that occur in arid regions where the land is not protected by a covering of vegetation. Dust storms usually start in desert margins rather than the deserts themselves, where the finer materials have already been blown away. As a steady wind begins to blow, fine particles lying on the exposed ground begin to vibrate. At greater wind speeds, some particles are lifted into the airstream. When they land, they strike other particles which may be jerked into the air in their turn, starting a chain reaction. Once ejected, these particles move in one of three possible ways, depending on their size, shape and density: suspension, saltation or creep. Suspension is only possible for particles less than 0.1 millimeters, 0.0039 in diameter. In a dust storm, these fine particles are lifted up and wafted aloft to heights of up to 6 kilometers, 3.7 miles. They reduce visibility and can remain in the atmosphere for days on end, conveyed by the trade winds for distances of up to 6,000 kilometers, 3,700 miles. Denser clouds of dust can be formed in stronger winds, moving across the land with a billowing leading edge. The sunlight can be obliterated and it may become as dark as night at ground level. In a study of a dust storm in China in 2001, it was estimated that 6.5 million tons of dust were involved, covering an area of 134 million square kilometers, 52 million square miles. The mean particle size was 1.44, a quarter, m. A much smaller scale, short-lived phenomenon can occur in calm conditions when hot air near the ground rises quickly through a small pocket of cooler, low-pressure air above, forming a whirling column of particles, a dust devil. Sandstorms occur with much less frequency than dust storms. They are often preceded by severe dust storms and occur when the wind velocity increases to a point where it can lift heavier particles. These grains of sand, up to about 0.5 millimeters (0.020 in diameter, are jerked into the air but soon fall back to Earth, ejecting other particles in the process. Their weight prevents them from being airborne for long, and most only travel a distance of a few meters, yards. The sand streams along above the surface of the ground like a fluid, often rising to heights of about 30 centimeters, 12 in. At a really severe steady blow, 2 meters, 6 feet, 7 in, is about as high as the sand stream can rise, as the largest sand grains do not become airborne at all. They are transported by creep, being rolled along the desert floor or performing short jumps. During a sandstorm, the wind-blown sand particles become electrically charged. Such electric fields, which range in size up to 80 kV/m, can produce sparks and cause interference with telecommunications equipment. They are also unpleasant for humans and can cause headaches and nausea. The electric fields are caused by the collision between airborne particles and by the impacts of saltating sand grains landing on the ground. The mechanism is little understood, but the particles usually have a negative charge when their diameter is under 250, a quarter, m, and a positive one when they're over 500, a quarter, m.